Okay, we're drawing this chart of the real number system. And there's two sides to our chart that takes care of all the numbers in the world that we could possibly have. The little side on the right is called irrational numbers, and the big side on the left is called rational numbers. So we just have those two titles right now. We're going to fill this in with a lot more information. So I wanted to first explain what rational and irrational mean, like in life, and then that might help you understand it better in math. So rational means that you could talk to somebody, you could reason with them, you could explain something to them, and they'd be like, oh, okay, that makes sense. All right? So rational numbers, I kind of think, are like that. They kind of make more sense. But irrational numbers, have you guys ever seen a 2-year-old throw a fit on the floor?
Yes.
Can you talk to them and say, oh, if you'll just sit in the chair nicely, then we could have dinner? And they'll do it?
No.
No. Will they just keep screaming on the floor?
Yeah.
And
Yes.
what happens if you try to put them in a chair? They sometimes they make their body stiff and they just slide right out of the chair. Have you ever seen that?
Yes.
Yeah, 2-year-olds are interesting. So I think of irrational numbers like that 2-year-old throwing a fit, because irrational numbers, they are a little crazy, okay? And you cannot stop them. So we'll talk more about those in a second. But rational numbers have 3 more categories inside the rational side. So we're going to draw some more boxes in here. We're going to draw one like this. And it could go all the way to the bottom, but leave a little space at the top and the edges. And then we're going to draw another one. And we're going to draw one more. Kind of like art class today. So irrational numbers, like that little 2-year-old that's throwing a fit, they go on forever. Sometimes you think that fit is never going to end, right? So an irrational number is a decimal that never stops and never repeats. So you might have 5.623196572, and on and on. And when you see little dots after a decimal like that, that means the decimal keeps going. Now, is there a pattern to those numbers after the decimal?
Write that down.
Yes. Do any of those numbers after the decimal repeat? No. That is an irrational number. When you divide a fraction out, and it gives you this long decimal that goes on forever, but doesn't repeat or have a pattern, that's irrational. The most common irrational number that you will hear talked about in math is called, does anybody know what this symbol is?
No. I messed up.
It's called pi.
Oh, yeah, pi.
And pi is the most common irrational number because scientists have done so many studies on it, and they have found that they've gone to like hundreds of thousands of numbers past the decimal, and none of the numbers have a pattern or repeat in a pattern. It's crazy. Like, pi just keeps going forever, and it doesn't repeat. That's okay.
Too many boxes.
So irrational numbers are decimals that go on forever, or it could be a fraction too, that when you divide the fraction out, the decimal goes on forever. Okay? Numbers just like crazy. So rational numbers are fractions or decimals that have an end, or sometimes the decimal repeats. For example, the fraction 2/3 equals the decimal 0.6666666 forever. Okay? So the 6 keeps repeating, but since it's a repeating decimal, it's rational because it's just saying the same number over and over. So any fraction that you can divide out that equals a decimal that either ends, like 1/2, if we divided that, it would be 0.5, so that's like a real short decimal, or a decimal that keeps repeating itself. Those are rational numbers, okay? Let's try another one. What if I do 4/5?
How many sixes are there?
4/5 equals 0.8. So that would be a rational fraction. Okay, it doesn't matter how many sixes. You can put as many as you want.
Okay. Six.
Oh, that's good. Okay, so rational numbers are fractions. Irrational numbers can be fractions too. But when you divide the fractions out, rational numbers have an end or repeat, and irrational numbers go on forever. The next type of number that we're going to talk about is called integers. Does anybody remember what an integer is? Integers are positive numbers, negative numbers, or 0. Okay? But integers are not fractions. So, in the integers box, I want us to write some examples. We could have -18. We could have 0. We could have 6. We could have 5,240. As long as it doesn't have a decimal or a fraction, it is an integer if it's positive, negative, or 0. Okay? So it's any whole number, positive, negative, or 0.
My boxes are a bit.
That's okay. All right, the next one is called whole numbers. And whole numbers start with 0 and go positive. Okay, so I'm going to draw this little start with 0 and go positive. So any number 0 or positive number, not a fraction, not a decimal. So we could have 0, we could have 1, we could have 42, 68, 3,000. As long as it's above 0 and it is not a fraction or decimal. Those are our whole numbers. And then the last kind of number is going to be our natural numbers. And natural numbers start at the number 1 and go positive. So natural numbers do not include 0, just positive numbers above 1. 1, 3, 75, 5 million. Okay, so any number that's above, it's 1 or above, and it's not a fraction or a decimal. That's our natural numbers.
What's the last one?
Okay, so in this section it says, name all the sets of numbers to which each real number belongs. So I have to look at the number they gave us, and I have to decide where on my chart does it fit. But here's the thing. If it is a rational number, thought I had the highlighter. If it's a rational number, it could also be another one of these. Okay? It could be all of those, it could be 2 of those, it could be 3 of those, it could be 1 of those. But if it's an irrational number, it's only going to be irrational. All right? So you'll see what I mean after we do a few. On this first one, look at the number they gave me. I have a decimal that is repeating. What is it repeating? What is it repeating?
It's repeating 050505.
050505. So if it's repeating that, guess what? Remember, repeating
Irrational.
decimals are rational. If it repeats, it's rational. So this one falls under the rational numbers. And remember, My integers, whole numbers, and natural numbers cannot be decimals or fractions. So this one only has rational for its label. Okay, Cameron?
But isn't it irrational because it goes on?
It's irrational if it doesn't have a pattern or repeat. But since this is 0505 and it has a pattern, it's rational. That's a little confusing, but the more examples we do, the better you'll get it. Okay, for number 5, now I have to solve it before I can decide where it falls. So what is the square root of 100? What is it?
Isn't that square root of negative
10.
So the square root of 100 is 10, and because the negative is on the front, I have to bring it down to my answer.
negative?
-10. Now, where on my chart could I put a -10?
Integers.
In integers. Good. So this one is integers, but guess what? If it's integers,
It's rational.
it's everything that comes above it. So what's above integer?
Rational.
Rational. So it's also rational. So this one has 2 answers. How about the square root of 17? Who's got that?
Can I answer it?
Okay, look at this number.
Oh.
It's 4.1.
It's integer.
What kind of number is it?
It's a common number because you see 1 twice. It is.
Is that irrational number?
It's irrational because there's a bunch of numbers in there, and I see some 5s more than once, and some 1s more than once, and some 6s more than once, but they don't repeat in a pattern. It's not like it says 1, 2, 5, 6, 1, 2, 5, 6, 1, 2, 5, 6. It's just numbers random, so that makes it irrational.
I wonder if they will the answers for every.
I don't know. Bunch of smart guys that came before us. Okay, and number 7. Now, what we have to do is we have to make let's make it an improper fraction.
Can I do it on
Yes.
the board?
No, not on the board.
Okay.
So-
3 times 4 is 12. Plus 1 is 13. So
Good.
it's 13 over 4.
Good, yes, so awesome. So we make it into this improper fraction so that now we can divide it on our calculator. Remember, fraction means divide. So I'm going to do -13 divided by, was it 4?
Yeah.
Oh, look, I got -3.25. So what kind of a decimal is that? Rational or irrational?
Rational?
It is rational. I think you're getting it. So let me write that. -3.25. And then, because the decimal ends pretty fast, it doesn't repeat, it doesn't go on forever, it is just going to be a rational number. Okay, so first we're going to estimate the square root to the nearest tenth of a decimal, so one place after the decimal. So the square root of 2 is about 1.4, but now we have to graph it. So where does 1.4 fall on my number line? Between which 2 numbers?
1 and 2.
Yes, great. So right there, and we're going to label it as the square root of 2. So you just put a little dot and write square root of 2 above it. Did you get that, Bella?
Now we go between 3 and 4.
So,
Wait, no, 4 and 5.
good. So the square root of 18 is about 4.2, and we got to put the negative in front. So -4.2, Cameron just said, would fall between -4 and -5. So you're going to write it, put a dot right there, and then you're going to put negative square root of 18 above it, because we always got to label our points on the number line, okay? And what about the last one? What is the square root of -30? Cameron?
Okay, the square root square root
Okay, so negative 5.4, which would fall between negative 5 and negative 6, and then we're just going to label it